This is Dr. Sarala, Head Department of Physics and Electronics. I will be taking your physics classes. I just want you to have some kind of an overview of what you will be studying in degree and to connect with what you have studied in intermediate. In intermediate, you already had some course on mechanics where you studied about kinematics, dynamics, and then laws of motion, that is Newton's laws of motion, circular motion, arbitrary motion, rotatory motion, okay, and the concept of vectors, how do you represent a vector, and how do you represent a scalar, and what is a scalar product, what is a cross product. This is, I think, this much done, and you also know about the conservative force, center of mass, motion of a particle under the influence of forces, the nature of the forces, behavior of the particle under the influence of force, and so on. Okay. Now, with this knowledge, what you've gained in intermediate, we will be moving on to the physics degree. We'll have 8 papers in physics spread across 8 papers, which are spread across 6 semesters. So, first semester you'll be studying about mechanics. Second semester is waves and oscillations, followed by optics, thermodynamics, electromagnetism, solid state physics, nuclear physics, and simple and basics of semiconductor electronics. I will be taking your first degree course on mechanics, and I'll be handling 2 topics, the central forces and relativity. So, before we start, I expect you people to have a complete knowledge and a thorough understanding of Newton's laws of motion, the different types of arbitrary, circular, and rotatory motion. Okay? So now, what exactly is expected is like this. Say, when you studied Newton's laws of motion, you studied about, you all know how to state the 3 laws of motion. The first law being that a particle or a body continues to be in its state of rest or uniform motion unless it is acted upon by some external force. So, this particular law gives rise to the definition of inertia. The inertia can be due to rest, it can be due to motion, or it can be due to direction. So inertia of rest means if it is at rest, it continues to be at the same rest position unless it is pushed. Pushing means applying a force. Inertia of motion, that is, if it is moving in a forward direction, that is, example is you are trying to catch a running bus, you are moving, and then suddenly a force is applied. You are in a bus is moving, and suddenly if a brake is applied, what will happen? It continues to be the same. So the upper part of the body continues to be in the forward direction, whereas the feet comes to a rest. So you'll have a jerk, that is motion. Similarly, if you want to catch a running bus, you will run a little while, get into the bus, and set into motion. This is an example that you get. Then you have inertia of direction. So it continues to be in the same direction unless it is acted upon by the force. So general example, what we do is you take a stone tied to a thread, you rotate it, and suddenly the string is slipping off the stone. It takes a tangential direction. So this is how you define your first law of motion. And we say what is important here to note is that when we say external force is zero, it also means that the external force is equal to, in addition to external forces, there may be some internal forces which are acting on the bodies. So, always external force is equal and opposite to sum of all the internal forces, and they are equal and opposite to each other. So, even in the absence of external force, if there are some internal forces present, sum of all the internal forces also is zero, then only the body will, then also the body will not be able to move. Okay, this is another. Then the second law states the rate of change of momentum is directly proportional to the external force, and this is a vector, so it takes place in the direction of force. So this is something. All of you are familiar with the famous third law, action and reaction are opposite to each other, but they act on not on a single body, but acts on two different bodies. So these are the three different laws of Newton. Now we will be discussing about what are the nature of forces. We have not only these mechanical forces, we have electrostatic forces, electromagnetic forces, gravitational forces, and nuclear forces. What the different nature of the forces? What is the behavior of the particle under the influence of the force? What happens? And if you want to describe the complete motion of the particle, we make use of mathematics, a set of equations. We write and we develop an equation, and we say this is an equation which describes the motion. That means we are making use of mathematics to describe the behavior of the particle under the influence of these forces. Then this is how we will be starting our course. Then we also talk about planetary motion or arbitrary motion, where we talk about Kepler's three laws. So the three laws, the first law says that all the planets revolve around the sun in elliptical orbits, and sun is one of its percent. The second law states that the rate at which the radius vector seems will be equal in equal intervals of time. That means the area velocity is constant. The third law says that the time period and the relation between the time period and the semi-major axis of the rays. So square of the time period is proportional to cube of the semi-major axis. This is what you already studied in your intermediate, and we will apply these laws. We develop an equation. We call it as equation of orbits, and we will prove all these three laws from the mathematical relationship. So this is the introduction for the first unit. The third, actually, in your syllabus, it is the third unit. Your syllabus is divided into 4 units. I'll take up central forces and introduction to special theory of relativity. Other two will be taken by Miss. So, with this introduction, generally, we will be having all these meetings because of this pandemic situation using a Google Meet link. The Meet link is being already shared in your Google Classroom, and the code of the Google Classroom is shared in your social networking class group. So I will be giving you some small exercises, some quizzes from what you know, and this is basically to ascertain and to know how much you have covered, because there are students coming from different backgrounds, different colleges. So to put you all on one single platform, we'll just give a small quizzes to know where you are, and then from there we will be starting other things. Okay, with this introduction, I once again welcome you all to this new academic year 2021. Welcome to St.Ann's College, Department of Physics and Electronics. Hope we'll all have a joyous learning together. Thank you.